these four maps of precipitation and temperature under two different types of models for a couple of reasons. One, that scale is really important and range is really important. The data here looks radically different between these four different maps. And maps are really important to geographers. I think that goes without saying. But spatial studies, location mapping has become really important for everybody. And so getting a little geography is important here in terms of understanding location and location variability. If we just look at the precipitation models, here's our precipitation across these two models here. What we see is we've got low variability here. We'll just take a look at the United States and Canada and not get into the nuances of the rest of the planet, just so we can concentrate on one area. Here we've got lots of variability in and around the lower mainland of British Columbia, Vancouver, into Seattle, Washington, and then this bluer shade that comes out across the Rocky Mountains and then into Canada. Here in the United States, we've got this yellow, which is sort of this middle range in precipitation. This is the amount of precipitation increase that's going to go on. So we're starting to see less precipitation, or pardon me, more precipitation here and less precipitation coming across here. If we take just this western area here and we look at it here, we see that the model is more gross, that it's not nearly as clearly defined, and that's scale and range. And what we want to do is recognize that when somebody brings their model forward, it's how accurate is it geographically. And I would argue that you would probably recognize that this is probably the more accurate of the two, right? We can delineate the change across this place here as more variable than across this place, across the same border region. So that's important. So this is precipitation. Temperature, we get the same phenomena. This looks for temperature like the entire world is on fire, right? And color is important. You want to stay to cartographic convention. And a lot of people don't do that. So be aware that, somebody might want to be making something look worse than it is because they choose red. If we take a look and choose a better designed map, we probably see the greatest volume of change, which is what these two models of temperature are showing us, is that there's going to be more change along these coastal regions here than throughout other areas. But look at this. Here's this right here in the United States, and out here, Maine, Vermont, is going to get a lot of change that we just don't see happening out here anywhere. Less volume of temperature change through here than and even less so across this part of the United States. Here, the range of change has been all lumped in. We're not seeing any variability or very little variability across, just a tonal difference through Quebec, parts of Ontario, and Nunavut through here that we also see across here. But other than that, really, really important. So always question the data set that you're looking at. Am I getting the detail that I need out of the information given? So 25 years ago, this might have been a spectacular map. 25 years ago, this might have been a spectacular map. Now we're looking at much better mapping occurring as a result. That brings us into this understanding of climate change, which is natural, and global warming, which is natural. And the question is, how do we pair out natural phenomena, warming or cooling that the planet undergoes, with what may or may not be a condition that is produced by humans? And that's brings us to having to pull out proxy data and measure against proxy data what the Earth ought to be doing versus what is actually happening in real time. So, with big picture climate change, we know that the Earth goes through very regular cycles of warming and cooling. And we can talk about those as glacial and interglacial, or ice age and inter-ice age periods. And those are those big, for thousands and thousands of years. The Earth is very, very cold and then very, very warm. And right now, let me be clear, we are moving out of a glacial period and we are in an interglacial period. We are still warming coming out of that glacial period. All right. Now, these, for the most part, are the product of variation in the Earth's orbit and in the Earth's tilt, but there are other conditions that produce these long-term climate changes as well. Now, over the last 200 years or so, the changes which have been observed do not fit as nicely into these regular cycles as the data suggests that it ought to, which tells us that something else is pushing the change that's observable. And the evidence now suggests that it's human-induced atmospheric change. So bear with me. I've got a number of slides here that will change scale and time, which then produces a complexity in recognizing what it is that we are undergoing.